This is Dr. Vahid Aryadus here. In this video, I'm going to demonstrate how to do a three-parameter logistic IRT analysis. Now, there are three IRT models, or item response theory models, one being 1PL, or one parameter logistic model, which is similar to the Rush model. The second one is a 2PL parameter model, and the third one is the 3PL, that's three-parameter logistic model. If you're interested to learn more about the technicalities of this kind of model, I would recommend that you read Birnbaum 1968. In addition to that, what I would like to suggest is that you take a look at our recently published paper in Studies in Educational Evaluation, which is a systematic review of item response theory in language assessment. If you are still interested to learn more about the technicalities of IRT models, so one of the best books is this Item Response Theory Principles and Applications by Hamilton and Swaminathan. Okay, so let's get started with our IRT analysis and see what we can get from the analysis today. There are a few steps to take before we start the IRT analysis using SPSS. We should remember that we need to have R 3.5 on your PC. If you have not installed it, please go to this website here and install it on your machine. That will be the first step. I'll leave this link in the comments section of this video below it, so you can just easily go there and download it. I think it should also work on Mac, but I'm not sure if it's exactly the same version. But I know that people have been able to install R 3.5 on their PC, on their Mac machines. So I've already done that. Let me show you. This is my R 3.5. Then after you install R 3.5, let me go to stage 4 and just quickly tell you what these four packages are. So one of them is called MASS package. You can copy this command, as I will leave it in the comments section again. Copy it and paste it into R and click enter. So after this window pops up, it's the CRAN mirror window. You can choose any of these options. I'm going to choose the first one on top and click OK. Okay, since I've already installed this, I got this sort of error message, but it should be fine. And the rest of them are going to be installed in the same way. You just copy and paste it into the R interface and enter, and you will install them. After doing this installation, then we go to our SPSS. And here is stage 2. In SPSS, we need to install stats underline IRM, and therefore I'm going to go back to SPSS through the extensions menu. In the previous video, I discussed how to connect your R with SPSS. Now, some of you might not have watched that video, so I quickly tell you how to do that. The first thing is that you need to make sure that you have this additional option, which is by default not there in SPSS output or in SPSS interface. What you should do is to add it before creating the connection between R and SPSS. So the first step is to go to Extension Hub, and yes, so after the connection is created between SPSS and the Extension Hub, since I've already installed the package R 3.5, as I have discussed in the previous video, I cannot find it under not installed, but you will be able to find it under this section, not installed. So what I want to do is to toggle between explore and installed and show you where that extension is and how it looks like, so that you can find it too. So if you scroll down, you will find stats R 35, which is actually 3.5. Now, what you will need to do is to click on a box like this in exactly the same place, but that box will be install extension. Because I've already installed it, I've got uninstall extension. So if I click this, it will be uninstalled. Anyway, so I'm not going to do that because I need it. And after you install, you just click OK, and it will be installed for you. That's the first package that you need to install on your SPSS. The other package that you need to install is called stats IRM, and that's again within SPSS itself. So let's look for stats IRM. It should be around here. So I've already toggled back to Explore under not installed, and I found stats IRM. An easy way to find it is to sort everything by name and then find it. Then get extension, click on it, and then click OK, accept, click finish, and you've got one extension installed, and click OK. Okay, now we'll wait for the results of this installation. Hopefully it will be installed fine. Okay, the bundle has been successfully installed, as you see from this message. The last thing we need to do is to go back to extensions, to click on R3.5 configuration, and enter the home directory of R3.5. We should go to our C drive and see, just copy in the address of R3.5 and paste it right here, and then click OK. I've already done that before, so I don't need to do this. So I'm going to click cancel. So after this, the installation and the extension are ready for the start of the analysis. Okay, what we need to do is to go to Analyze. Under this drop-down menu, go to Scale, and we'll find our Item Response Theory Model extension. Previously it was not there, but since we have installed it, we can find it. So I'm going to click on Item Response Theory. Remember that this is going to be a 3-parameter logistic model, so we will not get 1 PL or 2 PL. I have a few items here. 5 of them are grammar items and 5 of them are vocabulary. I can actually change the display, the variable to display names. And then out of these 10, I think I should have a kind of unidimensional scale. I'm going to move this to the right hand side under the item interface. And the next step is quite straightforward. I can click on Output, and under Output I'll get all the tables as well as all the plots. Next I continue. So now we are ready to go. We don't want to save anything, and we can just let SPSS to delete the missing values listwise. Let's click OK. Okay, nice. So the results are out, and I'm going to quickly walk you through the results. The first thing that we see here is the global fit statistics. As I mentioned in a previous video, we can use global fit statistics to compare different models. For example, you can compare the 3-parameter logistic IRT with the rush model. These are available under SPSS. As I have discussed in a previous video, you can do a rush analysis using SPSS under scale and rush model. Please watch that video to see how you can get this rush model extension. If you click on this, you'll see more or less the same sort of interface for rush analysis. You can get all the items in analysis. You can click on the output and then click OK. Why am I suggesting you to do this while you are doing a 3-parameter logistic model? I'm going to click OK. The reason is that then you can get the global fit statistics, which you can compare with the global fit statistics of the 3PL. So in other words, you will have a chance to compare the fit of your 1-parameter logistic model, that's a rush measurement, more or less similar to rush measurement, and your 3-parameter logistic model. Ideally, we should be looking into a comparative study of 1PL, 2PL, and 3PL. Unfortunately, so far under SPSS, we can only compare 1PL and 3PL, which is not too bad really, since I've already done that before. I want to show you the results. This is the output of 3PL, which I transported here. We are looking for the AIC statistics, which are smaller among two or more models. So the smallest or the smaller statistic of AIC belongs to the 3PL. On the other hand, the BIC statistic is smaller for the 1PL model. Now there are two schools of thoughts here. I'm not going to go through it with too much details, but remember that some scholars would prefer to look at AIC and to prefer this over BIC, whereas on the other hand, some scholars prefer to look at BIC, and they would say that the model which has got a smaller BIC statistic is preferable. Now I leave it to you to decide as to whether a 3PL or 1PL model in this scenario is preferable. I'm going back to the output of my 3PL model. And as you know, the 3PL model can give you three parameters: a guessing parameter, item difficulty parameter, and discrimination parameter. Guessing is students guessing on the item, and the range for guessing should be between 0 and 0.4. So I'm going to create a graph out of this guessing. We already see that everything falls between 0 and 0.4, and therefore these items do not invite a lot of guessing, which is good news for us. If it's larger than 0.4, then we'll have a problem. So I'm going to click on line, and here is the graph for the line, the graph for the guessing parameter. I double clicked on it. I just want to display the data labels. After click on that option, I can close these and I'll get the labels for the data. And this is really interesting because the highest guessing is right here, and I can go back to 0.355. That's really what we need to have in a good and productive statistical analysis. Item difficulty hypothetically ranges from -infinity to +infinity. So those items that are closer to the in difficulty are closer to the main bulk of the ability of the population or the ability of the cohort you're measuring would be better. Now, of course, we can also look at the standardized error of measurement here, and if you have a very high error of measurement, for example like this one, that item might not be useful at all. So this item V2, that's vocabulary 2, might have a kind of problem. So we need to look at that, or we might have to leave it out of the analysis. Next is the discrimination parameter. The discrimination parameter is basically analogous to the standardized loading coefficient in factor analysis. As a result, anything that falls above 0.3 seems to be acceptable, because we need our items to be discriminating between high ability and low ability people. So for this discrimination parameter, which I'm going to convert into a line graph again, I would say since quite a few of them are falling above 1, they are over discriminating among our test takers. For example, items 1, 2, 3, 4, and 4 under grammar, and also item 3 under vocabulary. What this means is that these items are either too difficult or too easy, that they are over discriminating in the sense that, for example, if it's too difficult, a lot of people have failed to answer that question. So the discrimination parameter gets inflated a little bit under these circumstances. So we don't really need an item that is over discriminating among our test takers, and unfortunately quite a few of these are over discriminating. Again, this is the graph. In the same way, you can create a graph for the difficulty parameter of your items. So let me quickly create a graph and just visually conceptualize the difficulty of the items. So the most difficult item based on this graph, let me also get the labels for our graph. The most difficult item is item number V4 with this difficulty, and the easiest one is item perhaps G1. Or am I, is it difficult? Yeah, it's the difficulty parameter. So it's minus 2.318. So let me just double check. Yes, this is the difficulty parameter. Okay, next is our fit statistics. This is different from the global fit statistics in the sense that we're looking at the fit stats for every single item. Preferably, we should not have any significant values, but you see that every fit statistic that you can see here is significant. SPSS outputs only this kind of fit statistics. In other software packages like Bylog or WinSteps, you can also get in-fit mean square values and out-fit mean square values, which are perhaps more suitable for a sample size like the one that I have in the present data set. My sample size is around 1,800 plus people. This graph is also useful in the sense that it gives us a kind of plotting of proportion correct against the total score. For example, if you have a total score of 8, those people who have a total score of 8, for item 9, the proportion correct of item 9 is around 50%. Let me draw this for you so it will be easier to imagine. So for item 8, for the total score 8 and item 9, those people who have item whose proportion correct is around 0.5 for item 9 typically have a total score of 8. On the other hand, if you are looking at an item like item 1, which seems to be very easy, if your total score is 8, total score on the entire test is 8, then your proportion correct, the proportion correct on item 1 is around 0.9 something or even 1, meaning that if your total score is 8, your chances of answering what item number 1 is very high. So the chances are that you will answer item number 1 correctly. Next is our kernel density estimation graph, which is basically a frequency graph. So the frequency of those people whose ability fell around here is a lot more, between -1 and +1 logits, is a lot more than those people who fell on this side of the graph. We have a lower frequency on this side as well. So this is basically what kernel density estimation is about. It provides us some similar information with the right map, but only for the person ability parameters rather than item difficulty parameter. Because as you remember, the right map has got two sections, the person parameters and item parameters. Okay, now I'm going to move down to the item characteristic curve. As you see, item characteristic curves are quite different from those that I presented in a previous video in which I used rush measurement. It's because that the slope and the intercept of items have changed. For example, for item number 1, which is G1, we've got this slope, which is kind of similar to the slope of the second item, that is G2, but it's obviously, these two items are obviously different from an item like V2, if you can see that. because the slope is quite different and is intersecting them. Items V4 and also V1 are also intersecting other items in terms of their because they have got different degrees of slope. This indicates that, and also their intercepts are different. This indicates that their discrimination and guessing parameters are quite different. So it might be a better idea to use a 3-parameter logistic model under this circumstance if we go by, as I mentioned before, we go by the AIC parameter being superior to the BIC parameter, or the BIC metric, I should say. Okay, finally, we can look at this item information curve, which provides more information about the amount of information that each item is providing. I have explained this in another video, so I just very briefly touch on what I have talked about previously. For an item like the one in blue, I suppose this might be one of the grammar items, I'm not quite sure about it. So the main bulk of information falls in this area. So which means that in this area we can get the highest amount of information about the ability level of each of the test takers in this region. And as a result, we can claim that this item is most construct valid in this section or in this region. Whereas for another item, for this one that has been represented in green, the main bulk of the sorry, I should change this now. The main bulk of information for the green one here falls within this region, which again means that the amount of information that we can get for our test takers using this item will be a lot more in this region. And therefore, the amount of construct validity is much higher under this part of the curve for this item. I suppose it might be item. I don't know what item it is. It's very difficult to identify. So that's how we can make sense of this item characteristic curve. So thank you very much for paying attention to this video, and I really hope that you find it useful. If you did, please give it a like and stay tuned in. There will be more videos on doing different sorts of analysis in IRT in the near future. Have a good day.